Hey Opties! Today we're talking about standard form of a quadratic. Our formula is y equals ax squared plus bx plus c. So notice we've got a squared piece, an x piece, and then just a number piece, which is that c. And a, b, and c are all constants, which means they're just numbers. Let's take a look at what the numbers represent. Your a is just like the a in vertex form. If the absolute value of the number is greater than 1, then it's going to be a vertical stretch. And if it's between 0 and 1, it's going to be a vertical shrink/compression. If your a is less than 0, which means it's negative, then that's going to be an x-axis reflection. Remember, for a quadratic, that means it's going to open up downwards. It's going to have that end behavior as down, down. And c is the y-intercept. Since if you substitute 0 in for x into the equation, then you just get y equals c. Let's talk about how to find the vertex given a standard form equation. So we want to use this handy dandy formula. The x value is negative b divided by 2a, where b is that x coefficient and a is the x squared coefficient. Remember that coefficient just means the number being multiplied by a variable, and it's typically in front of the variable. And if we want to find the y value, so our k, because remember our vertex is h, k, our k value is just whatever y value you get when you substitute your h in for x into the equation. And that's all you do. You do that function evaluation, that f of negative b over 2a. So what if you're given standard form equation and you want to write that equation in vertex form? So you're converting between the two forms. The first step is to find the vertex. So find your hk. And then you're going to use your hk and the same a value that's in your standard form, and you're going to substitute a, h, and k into your vertex form. Remember, vertex form is y equals a times the quantity of x minus h squared plus k. So since x and y are your variables, a, h, and k are all you need to find the vertex form. So use that negative b over 2a and that function evaluation and the same a, and you'll get there. Let's do some practice. Number 1 says, what is the vertex form equation of y equals x squared plus 12x minus 3? Okay, so our h, which is our x coordinate of our vertex, is going to be negative b over 2a. So b is going to be that coefficient of your x. You see that here. It's the number on the x. So that's going to be 12, but we want to do opposite b, or negative b, so it's going to be a negative 12. And then we divide by 2 times a, so 2 times whatever a is, which is a 1 in this situation. We know it's a 1 because remember, if you just have a variable, the coefficient is 1 because 1 times anything is itself, so you don't actually have to write that 1 in front. So that's just going to be a negative 6. Now we want to find k by substituting our negative 6 into our given equation. So 6 squared, or negative 6 squared, when you square it, it doesn't matter if you have the same sign, but we'll write negative 6 just to be sure, plus 12 times negative 6 minus 3. So negative 6 squared, or the quantity of negative 6 squared, is 36. And negative 6 times 12 is negative 72. And then we have our minus 3. Okay, so let's just finish this off. 36 minus 72 is negative 36. And then we're still subtracting our 3, and that's negative 39. So finally, let's write our vertex form. It's y equals a, which is 1, times the quantity of x minus h, so x plus 6, because we've subtracted our negative 6. That squared, and then we have our plus k, which is going to be that negative 39. So that's it for that one. Number 2, you try to cross a troll run bridge every day on your trip to the market because, I mean, it's closer to your house, right? And now that you've learned about standard form quadratics, you finally know how to answer the troll's everyday question. How high above this stream is the bridge? Okay, so that's going to be the maximum. So the very tip top of the bridge, the maximum of this given equation. So we're gonna find the max. We know it's a max because it makes sense in the context of the problem, and also because there's a negative a value. And our max is gonna be that k value. So we're gonna try to find k. So here's our strategy. We need to use negative b over 2a to find h, then do function evaluation with h as x and find our k. So let's do that. Our h is negative b, which is negative 0.513, over 2 times a, which is negative 0.000567. Okay, I'm going to type this in my calculator on Desmos, which you know is an amazing calculator, and then figure out what this h value is. Okay, so we get approximately equal to, which is what the squiggly lines mean, 452 and 381 thousandths units. So it doesn't tell us the units, but it could be like feet or meters, probably feet. You know, one of those two make most sense. So now let's find our k. We're going to take this h value and substitute it for x into our original equation. So negative 0.000567 452.381 squared plus 0.513 times 452.381. You could type this directly into your calculator if you'd like instead of writing it out, but just for the sake of doing this problem, for us to see all the steps, I'm writing it out. So I'm going to figure out our k value by substituting this in our calculator. Okay, so we got 116.036 units, and you know, the units again could be feet or meters or something. And that just tells us how high from the stream the bridge is. And that's the max. And we could write a little sentence to say the bridge is this much higher than the stream. So that would be a better way to answer your question, but that's the number we get. Number 3, which of the quadratic functions below have the highest maximum value? Okay, so the max is the k value. So for function b, I just went to that one because it's an easy way to figure out the max. That's just going to be 6 because it's that plus 6. It's that k value. For function c, well, recall that you have a maximum. It's going to be symmetrical about that axis of symmetry. So we're going to look for the y value that has symmetry around it for its y values. So notice we have the 6 repeated and the 12's repeated. So what's in the middle is the 14. So that's going to be a max of 14. So far function c is winning for the highest maximum, but we want to make sure that function a does not beat that. One way you could do this is you could type this in Desmos and click at the max, and you could see if it's higher than 14 or not. But let's do it by hand just to practice our negative b over 2a skills. So our h is negative 8 divided by 2 times negative 3. And then that's negative 8 divided by negative 6, which is going to be a positive. And if we take out a 2 in each of these to simplify, it's going to be positive 4 over 3, so 4/3. Now let's substitute to find our k. So negative 3 times 4/3 squared plus 8 times 4/3 plus 1. Okay, so negative 3 times 4/3 squared is the same thing as 4 squared divided by 3 squared. So it's 16 divided by 9. Plus 8 times 4/3 is the same thing as 8 times 4 divided by 3. So 8 times 4 is 32 divided by 3, and then we have our plus 1. Honestly, this is getting pretty messy with the fractions, so I don't really want to find a common denominator, which is what you'd have to do to do this by hand. So I'm just going to put this in my calculator and figure out our final k value. For all of this, we get 6.3 repeating, So function C does indeed have the highest maximum. All right, Opties, that's it for standard form of quadratic. See y'all next time.